In this video, you're going to learn how to differentiate a function using product rule. Let's consider this first question. But let's understand when to apply product rule. These are separate functions. Let's differentiate exponential x. From the basic derivative table, if you differentiate exponential x, you are going to get exponential x. Hence, the derivative of exponential x is exponential x. Next, let's differentiate sine x. From the basic derivative table, when you differentiate sine x, you are going to get cos x. Hence, the derivative of sine x is cos x. We can do same for other functions. When we put together two separate functions in one question, like this, then we're going to be thinking about product rule. In the formula, we're going to call this u, then we're going to call this v. If u is a function and v is another separate function, then the dy dx will be, we're going to keep u constant and then differentiate v. Then we're going to use a plus and keep v constant. Then we're going to differentiate u. This is product rule formula. We can apply this to any other function put together. Let's go back to the question and see how to apply product rule. Let's find the derivative of this function. In this question, we got two functions put together. I will keep x to the power of 4 constant. Then I'm going to differentiate exponential x. The derivative of exponential x is exponential x. Next, I will put a plus, which is a requirement from the formula. Next, I will keep this exponential x constant. Then I'm going to differentiate x to the power of 4, and my answer is 4x to the power of 3. Remember the general rule of derivatives. Next, rearrange the function. Next, factorize. That is what is common on both sides of this sign. Exponential x is common. Likewise, x to the power of 3 is common on both sides. On this side, x is remaining, and on this side, 4 is remaining. And from the options, our answer is A. X plus 4 or 4 plus x. Both are the same. This is our final answer. Next, let's find the derivative of this function. The first step is to keep x constant. Next, we're going to differentiate sine x. The derivative of sine x is cos x. Hence, I'll write cos x. Next, I will put a plus. Next, I will keep sine s constant, and I will differentiate x, which is 1. Rearranging the function, this is our answer, and from the options, our answer is C. Next, find the derivative of this function. To solve this, keep 2x constant and differentiate cos x. And from the basic derivative table, when you differentiate cos x, you're going to get minus sin x, which is this. Then put a plus. Next, you put cos x constant, differentiate 2x, and your answer is 2. Rearranging the function, this is our final answer, which is option B. Next, let's consider this question. To solve this problem, I'm going to keep this constant and differentiate this. If you differentiate x squared, you're going to get 2x. And if you differentiate 3, you're going to get 0. However, I'm going to let the 0 out. Next, I will put a plus. Next, I'm going to keep this constant. And I'm going to differentiate this. Differentiating x to the power of 3, I'm going to have 3x squared. And differentiating 4, which is a constant, I'm going to get 0. However, I'm going to let the 0 out. Next, expand the bracket. That is 2x multiply x to the power of 3. You are going to get 2x to the power of 4. Next, 2x multiplied by 4. You are going to get 8x. Next, remember the plus. Next, 3x to the power of 2 multiply x to the power of 2. You are going to get 3x to the power of 4. Next, 3x squared multiply by 3. You are going to get 9x squared. Next, 2x to the power of 4 can add 3x to the power of 4. And you will get 5x to the power of 4. Next is the 9x to the power of 2 and 8x. Nothing else can add up. Hence, this is our final answer. From the options, our answer is D. Next, consider this question. If you solve correctly, your answer is D. You can equally factorize your answer to have this. Next, let's consider this function. To solve this product function, you will need the knowledge of chain rule to differentiate each separate function. How to apply chain rule has been treated in a separate video. However, I'm going to apply chain rule to each of these functions when differentiating it in this product function. Product because they are multiplying. Let's recap. By chain rule, to differentiate this function, we are going to differentiate minus 2x, and our answer is minus 2. And these 2 will multiply these 2. Next, we're going to recopy back this, and our answer will become minus 4 exponential minus 2x. Likewise, to differentiate this, let's differentiate 3x, and our answer is 3. Next, let's differentiate cos, and we're going to get minus sine. We're going to recopy back this 3x, and this is our answer. Check out the video on chain rule. To solve this problem, when I differentiate this, I'm going to have this. Likewise, when I differentiate this, I'm going to have this. I'm going to keep this constant. When I differentiate this, I'm going to have this. Next, I'm going to keep this constant. When I differentiate this, I'm going to have this. Next, minus 3 multiplied by 2. You're going to get minus 6. Next, you just join the remaining variable. Next, this minus will multiply plus, and you're going to have a minus. Next, you just rearrange the remaining variables. You can decide to leave your answer like this, or by bringing this over to this side, or you can switch this around. Both are the same. From the options, our answer is A. Next, consider this question. Here, we are given 3 separate variables. Remember that log x to base e is the same thing as the natural log of x. And when we differentiate the natural log of x, our answer is 1 over x. Always remember the basic derivative table. To solve this problem, I will keep the natural log of x and exponential x constant. Next, I will differentiate sine x, and my answer is cos x. Next, I will put a plus. Next, I'm going to put sine x and exponential x constant, and I'm going to differentiate the natural log of x, which is 1 over x. Remember to put it in bracket. Next, I will put a plus. Next, I will keep sine x and natural log of x constant. Next, I will differentiate exponential x, and our answer is exponential x. Next, exponential x is common. I will factorize exponential x out, and this becomes our dy dx. From the options, our answer is C. Next, let's consider this question. Here, we're going to keep x to the power of 3 constant. Then, we're going to differentiate cos x, and we're going to have minus sine x. Next, we're going to put a plus, and we're going to keep cos x constant. Then, we're going to differentiate x to the power of 3, and our answer is 3x squared. Next, we're going to open up the bracket, and we're going to factorize x to the power of 2 out. Rearranging this and factorizing x squared out of the function, this is our dy dx. From the options, our answer is A. In the next video, we are going to consider a tricky product rule function involving chain rule. And in the subsequent video, we are going to consider quotient rule, when and how to apply. This is calculus. Check out for all pre-calculus and calculus videos, including many other helpful videos. These are recommended video topics in differentiation, and also some suggested video topics in integration, including their applications. To solve differentiation and integration problems efficiently, always remember these formulas and notations. including pre-calculus video topics. To locate all these videos, follow the link on the screen. I will see you in the next video.